Good morning students. So in this session we are going to see one example for basic operations on signals. So let's take this question. A discrete time signal x of n is shown below. Plot the following signals. So we need to plot x of n minus 2, x of n plus 1, x of minus n plus 1, x of minus n, x of 2n, x of minus 2n plus 1. Okay. So we'll plot one by one. So first we'll plot x of n minus 2. Okay, so since it is a discrete time signal, so we have to mention it within the square bracket. Okay, so this is the time shifting operation of the original signal. Okay, so original signal means we have to do the reverse operation, that is here x of n minus 2. So we have to add plus 2 with the n values. Okay, so after that we will get the delayed signal, that is the signal is going to shift it towards right side. Okay, so if I add 2 with the time sample values, so minus 1 plus 2 it's 1. Okay, and 5 plus 2 7, then the new limits will be 1 to 7. Okay, so mostly student will leave this two samples, that is in at n equal to minus 1 and n equal to 0, its value will be 0. Okay, but in the question they are mentioned at n equal to 0 and n equal to minus 1, its value is 0. So we need to consider these two values also, otherwise the answer will be wrong. Okay, then the new limits will be 1 to 7. N. Okay, so minus 1 plus 2 plus 1. Okay, so at plus 1 and plus 2 it's 0, and so I am going to drag the signal towards right side. Okay, this is x of n minus 2. Okay, next we'll see x of n plus 1. Okay, so here n plus 1, so we need to subtract the sample values, that is n values, by minus 1. Okay, so if I subtract means minus 1 minus 2 and 5. So why I am considering only first and last limit means, so it is easy to plot if we know the new limits. Okay, and that is initial and final values. Okay, so minus 1 minus 2, 5 minus 1 4. So then the new limits will be minus 2 to 4. The signal gets shifted towards left side. Okay, so at minus 2 and minus 1, its value is 0, and okay, so this is x of n plus 1. So next we'll perform x of minus n. So x of minus n means the time reversal operation. Okay, so for time reversal operation we need to flip the signal about the y-axis. Okay, so if I flip the signal about y-axis, so whatever signal present at the left side gets referred towards the right side. Okay, so this minus 1 value gets moved to plus 1. Okay, 0 0. At plus 1 its value is 1, so it's moved to minus 1, and 2 and 3 its value is 2, it is moved to n equal to minus 2 and minus 3 positions, and at n equal to minus 4, 1, and at n equal to minus 5, it's 2. Okay, so this is x of minus n. Okay, so next we will do x of minus n plus 1. Okay, so in this case we have to perform time reversal as well as time shifting operation. So for that we need to first plot x of minus n and then x of minus n plus 1. Okay, so already we have x of minus n here. So this is the time shifting operation of the reversed signal. For reversed signal we have to do the same operation, that is here minus n plus 1. So we need to add plus 1 with the n values. So if I add plus 1 means minus 1 plus 1 minus 4 and 1 plus 1 2. Then the new limits will be minus 4 to plus 2. Okay. So this signal is going to be shifted towards right side, okay, by the sample 1. So what are present at n equal to minus 5 get shifted to n equal to minus 4. Okay, so at n equal to minus 4 it's 2 and 3 it's 1 and so we'll got the signal like this. This x of minus n plus 1. Okay. So next we'll do x of 2n. Okay. This is time scaling operation. Okay. While doing time scaling operation for discrete time signal, so we have to be careful because in time scaling operation we need to divide the scaling factor with the n values. Okay, we should know that for discrete time signals n value should be discrete, that is minus 1, minus 2, minus 3 and 0, 1, 2 like that. It should not be decimal values. Okay, so while dividing with the scaling factor, if you got any decimal values for n, we need to discard the entire sample. Okay, so in this case, so we need to perform x of 2n. So here the scaling factor is 2. So we need to divide the n values with the 2. Okay, so if I divide the n values, that is x of n values by 2 means, so here it will be minus 0.5. Okay, and 0 plus 0.5, 1, 1.5, 2, 2.5, right? So if I divide the time limits by 2 means, so I will be getting the new values like this. Okay, so we should remember that n value should be in the discrete intervals, that is it will be whole integers, 0 plus or minus 1 plus or minus 2 like this. Okay, so we need to omit the decimal values. So if I omit the decimal values, I will get the samples only at n equal to 0, n equal to 1 and n equal to 2. Okay, then the resultant signal will be this x of 2n. At 0 its value is 0, at 1 its value is 2, at 2 we should consider this as a n value for x of 2n. Okay, so at 2 its value is 1. Okay, that is we need to divide the scaling factor with the n value. If you got decimal values of n, just you have to discard the entire sample. So wherever you got the whole integers, just plot the corresponding sample values. Okay, so this is the x of 2n. So next we will see x of minus 2n plus 1. Okay, so in this case we have time reversal, time shifting and time scaling operation. Okay, so if we follow the priority, first we have to do time reversal operation, that is x of minus n. Okay, so after that we need to do time shifting operation, so x of minus n plus 1. Okay, and after that we need to do time scaling operation, that is x of minus 2n plus 1, right? So already we have x of minus n here and x of minus n plus 1 here. Okay, so I am going to directly scale the signal x of minus n plus 1. Okay, so if I want to scale the signal means just we need to divide the time limits, that is n values, by the scaling factor. Okay, so here the scaling factor is 2. So if I divide the n values by 2 means, so here I will get minus 2, minus 1.5, minus 1, minus 0.5, 0, 0.5, 1. Okay, so if I omit the decimal values, so I will get the samples at n equal to minus 2, n equal to minus 1, n equal to 0 and n equal to 1. Okay, then the resultant signal will be, that is x of minus 2n plus 1. At n equal to minus 2, its value is 2. And at n equal to minus 1, again it's 2. And at n equal to 0, 1, and n equal to 1, it's 0. Okay. So it's all about basic operations on signals. Okay. So if you have any doubts, you can mention it. In the next class, we will see classification of signals. Okay. Thank you.